Before we concern ourselves with the fetch, decode, execute cycle, memory registers and CPU components, let's make sure we've got one thing straight. What is it that a CPU does? What is its purpose? To try and help us understand, let's go to deepest, darkest space and listen into a conversation between two robots.
What is the purpose of the CPU?
It's the brain of the computer.
But what does that mean?
It's like a human brain, but different.
So can the CPU think?
No.
So at least we understand now that the CPU is definitely not the brain of the computer. But that only takes us so far. We know that it sits on the motherboard and we know that it's involved somehow in calculations. To deepen our understanding of the CPU, let's think about its purpose in terms of running programs, because fundamentally that's what computers are for. So let's look at programs in more detail. Computer programs are written in high-level languages like Java or Python. They're then compiled into machine code, and it consists of long strings of binary numbers. And so what are these binary numbers? Well, they're either instructions or data, and these are the instructions the CPU will execute one at a time, one after another. It's the speed at which the CPU can execute these relatively simple instructions one at a time that makes them so useful to us humans. A 3.5 GHz computer can execute 3.5 billion instructions per second. Let's drill down even further and look at an example of an instruction. Let's look at this example, load 1000. The load is self-evident. Either an instruction or data will be loaded into memory. But what does the 1000 relate to? You may have got there ahead of me. The 1000 refers to an address, a memory address, the place where the instruction or the data is located. Our picture is becoming far fuller of the purpose of a CPU. We now know that it executes instructions by opening, loading, saving, adding, subtracting. But also it needs to know the physical location of the instruction that it's going to use and where to save the data once it's been executed. Now we have everything pointing in the right direction to understand how a central processing unit works at a deeper level. Let's recap on what we've learned so far. Firstly, a computer is a programmable device, and CPUs are designed to run computer programs. Secondly, computer programs are written in high-level languages like Python or Java. They're easy for humans to understand and learn. Any code written in these languages is referred to as source code. Thirdly, the source code has to be converted or compiled into a low-level language in order to be executed by the CPU. This process is completed using an application called a compiler, and the resulting code is represented by long strings of binary numbers, and this is known as machine code. Fourthly, machine code, those binary strings we talked about earlier, they only contain either data or instructions. The fifth point we covered is that the CPU requires the address or location of the data or instructions that it's going to use, and it also needs the address or location of where it's going to save the results of any calculations that it performs. In the next video, we'll look at the components of the CPU and how they fit into the fetch, decode, execute cycle. In the final video, we'll look at the fetch, decode, execute cycle in granular detail. I hope you've enjoyed this video. Please don't forget to like and subscribe if you want to be the first to see new content. Bye bye.